All right. Hey, folks. Thank you for joining the CDS for CephFS for the Tentacle release. I'm putting up the link to the pad where we have topics for today. Links in the chat. Okay, I guess we can get started. The first topic in the agenda is insensitive directory trees. Patrick, do you want to talk about this?
Yeah, I don't really have anything to add beyond what we talked about at the CDM last week, which was also recorded. But this will be a priority for the Tentacle release. It's likely it'll also be backported to Squid. And the basic idea of this is it's going to be a client-driven implementation of case insensitivity, piggybacking off of the alternate name metadata, which was added for the use of FS script, but can also be safely used in a layered fashion with implementing a case folding out algorithm. I've already started working on it. I hope to have it done soon. If anyone has any follow-up comments or questions regarding the feature, please go ahead and post them here. Otherwise, I think we can just move on to the next topic. Guess not.
It's like next one's yours too, so.
Sorry, what'd you say, Greg?
It's like the next one is yours too. Hierarchical layout transformation.
I didn't add this to the agenda. Benki, are we going to try to make this happen for Tentacle? Okay, Benki's rejoining. So I guess I can talk about this a little more. It's been a while since I wrote this, 5 years actually. I mean, the basic idea of this is that we can set an X adder on a tree. It's hierarchical, and you just set what the desired layout for the files in that directory should be, and the MDS will just slowly chew through it, migrating data off of the old transformation or layout and transforming it onto the new one, just doing a data copy. And it has to acquire locks on the file to prevent readers and writers from clients. It will probably require a new lock because even the exclusive lock on the file lock does not or allows clients to buffer and cache data, although that may not be a problem as long as they can't read or write new data. That'll need to be investigated. Normally the MDS doesn't do anything like this. And then also allow clients or notify clients that the layout has changed. Right now, I think clients assume it's a static structure associated with the file. So I think in general, like it's a fairly simple thing, but the devil's in the details. There's lots of assumptions in the code, especially regarding file layouts not changing. Benki, I was asking you if we're planning to make this a priority for Tentacle.
Yeah, I think it's a good feature to add, and we have some downstream push for this too. So yes, uh, it doesn't look like it requires, really lots and lots of plumbing work, but most of the things seems to be like already in. We can like, you know, we have migration queues. We can reuse probably lots of code. Yeah, I think
I
so.
mean,
It's a good feature to.
steering is always harder than you think it is. I don't love this. Like we're gonna have to go through and update everywhere that talks about pool light like layouts or pool IDs, which offhand is like all the back traces for every file in the system or for every file that's getting moved. And I don't think any of these are going to be particularly hard, but you just have to know they're all there and touch them all. And if you miss one of them that's used for data redundancy and then get into trouble with this, it's broken. I do see another ticket that's marked duplicate from a month ago, where someone tried to copy pool and it didn't work. And like if the only thing that they're trying to do is move from a hard drive to SSDs, you can do that with Crush. So you super don't need anything in CephFS for it. Like if we want to do hierarchical file stuff, we can. I'm just this seems like a weird way to go about it.
I mean, we already have hierarchical data layouts. It's really just a matter of being able to change the data layout on a file without having to create new inodes and new directory trees, which is a fairly expensive operation, especially considering the client has to actually read the entire tree, which just creates a lot of traffic in the MDS cache. And it can be avoided if we just have teach the MDS to do it. Usually the MDS has plenty of spare bandwidth to handle this kind of operation.
I mean, if we did something like this in the MDS, we wouldn't be using its bandwidth. We'd do Rados copy from ops. So if we're not like any copy will happen inside of the Rados cluster, but
And Greg, you mentioned about like failures in between the migration. Is that also, sorry, I didn't get that totally. I mean, failure what due to some Rados error, and then because this thing will go keep on retrying till the migration is done. So are you worried about like stall client IOs?
no, I mean like if you go through disaster recovery, like there's a lot of ways to think you have succeeded in building this correctly and then find out you're wrong at a really bad moment. Like for the migration to say it succeeded and for regular file IO to continue working, and then something goes like something happens and you're trying to run the FS check tools and discover that it's totally inconsistent. Like I'm not saying that would happen.
I think the problem is a lot more difficult when you try to do it from some client application versus trying to do it in the MDS in terms of making sure that it's fully consistent. It's really quite painful if you try to write an application that'll do it in a way that's robust for any kind of failover situation. Whereas the MDS could potentially journal as it's going and make sure that it has exclusive access to the files.
I don't think it's guaranteed. I mean, we could build it. I don't know who's gonna be doing it, and Sorry, I'm just like what I'm seeing here is just kind of thin. That's all. But I'm not.
And you did say
Yeah.
this is like easily achievable or rather close to being achievable via some crush rule.
So,
How
well,
would you?
I don't know how to. I've never heard of this before. I'm looking at it and I see that a month ago there was a SigmaMark duplicate to move from hard drive to SSD pools, and that ticket, that's just a crush rule change. You like change the device class or whatever, and Rados does it, and CephFS isn't involved at all.
Yeah, that's true. But I think so yeah, that other ticket could have been done with a crush rule change. But as far as migrating a subset of files, they can't really be done with a crush rule. You want to be selective about what you move over to a different
Yeah.
storage class.
Hi, Patrick, this is Andres. We also have a use case that I do a lot is to move files to an erasure-coded pool from a triple replicated pool where they get written to by default when they're large. So obviously small files, we don't want erasure code, so we don't want to really mark whole directory trees as erasure code for the erasure-coded pools. Since tiny files end up there, which are then a performance problem. So what we do is we just do triple replicated writes, and then in the background move files to the erasure coded pool that are large. And right now, that the way we're doing it is some external process through POSIX, obviously. That changes the inode number, which is less of a problem, but it also has a small hole when we actually move the hard link over. If clients kind of access it exactly at the right time, it could create a problem. So if the MDS had some way of moving data between pools, that would be useful for that case as well.
Yeah, I think you also want like more nuanced control of when and how files are moved over, and that's not really captured in this ticket. Because right now it's, at least as it's currently outlined, it's just a simple xadder on a single directory that applies to all of its descendants. But if you want to be able to only move, say, large files, we would have to expand it somehow.
We just mark the file, the particular file that we want to move with the new pool, and move it. For example, I'm not less interested in doing this in a hierarchical way, but more interested in doing it in such a way that clients don't notice any hiccups if they do something in the middle of the move.
Okay.
Because right now what we do is we move the files at least 2 weeks after they have ever been written to kind of minimize the chance of a write happening during this procedure. Because it's really cool.
That would probably be an appropriate case for encoding such logic in the client rather than in the MDS.
But also lots and lots of clusters probably now are thinking of SSDs, so are we, and having some external process control what gets into the SSD layer versus the slow spinning disks would also be helpful, and some help from the MDS would be needed to move the files around also. So a la hierarchical storage management type things.
Yeah. I think the other reason why we wouldn't want a client to do this is that necessarily the inodes would change, which would complicate things like snap diffs that we would compute. Is basically the entire tree would change, even though the content of the tree has not changed at all. So I think that's another argument in favor of having the MDS do this, because nothing would change about the inode except the file layout.
Wait, that actually brings up a good point. How do snapshots work with this?
Yeah. We'd either have to recreate the snapshots, or, which sounds awful, or just not do it for snapshotted files.
Well, I mean, that's a non-starter.
Yeah, it kind of is.
Um, like we dude, I'm trying to think through how this would have to look. Like we either keep those old versions of the snapshot of the files on the old pools, which if you're using it for HSM, you super don't want because you're like trying to get it off of your fast storage or something.
Yeah.
And now we've got taking up all the space, or
It would probably require some
we do like
special support in Rados, perhaps. But that sounds that's makes it a much more difficult project.
yeah, and like and we'd be right in man. Let's see, we're self-managed snapshots, so we could write old files with old snap IDs, even if we've already moved on past those snap IDs on other objects. So maybe we could hack something together with like writing all the snapshots in order, and then using like the snapdiff stuff to preserve them all.
Yeah.
I don't think copy from. I don't think there's there's an existing Rados API to just move a whole object and its snapshot history. And you know, in a normal CephFS file system, those snap IDs are desynced anyway. Let's see, is that actually a problem or not? No, we have globally unique snap IDs. So we could use old ones on an existing pool.
Yeah, I don't
I think we
just
need to
reuse the
build
snap
Rados
IDs.
APIs. Yeah, I think we need to get a new Rados API to like the object history or something. But that would get really gnarly to think through properly.
So
Mhm.
in CephFS, we're using a single snap monotonically increasing sequence number for snapshots across all data pools. So I think it should be in principle safe to copy older snap IDs to another pool or even another namespace in the same pool. So just a matter of making sure we copy the full object, which with its snapshots. And I suppose if you just pass the same snapshot vector you would use for write or read as part of that copy operation. But yeah, support for that would need to be built.
I don't, well, yeah, and it's not just building, like, Rados doesn't, I think, have a great way of reading all the data related to a snapshot, related to an object in any snapshot. Like it doesn't really have APIs for that down to the object layers. I think it would still itself just be scraping together like across all of the version. I'm not actually sure if that's possible to do like efficiently or not. Oh, I'd have to
Okay, so
talk to
I
the Rados
think it's
team.
clear this is
Yeah.
more difficult than we thought, and actually, I think just considering the snapshot angle makes it more appropriate for the MDS and Rados to try to implement this, because the client application simply can't do the migration in an efficient way.
Yeah, but I mean, yeah, we clearly don't have a design for this, so if it needs to happen, someone will need to solve that problem first.
Agreed.
And by efficient, you mean taking care, like making it such that neither the client nor the MDS ever kind of read and write the actual data, so that it's done by Rados.
I think that's ideal, but like if the MDS does it, it's not like strictly necessary.
I mean, I'm also concerned about not inflating data space, like actual space usage. I don't think the OSD internally has, like the internal interfaces in OSD uses to read a file, or it passes or not a file, but an object, or it passes the snapshot, like the snap ID and the object name through an object store interface that talks to Blue Store or C Store and Crimson. And that pulls out the necessary data. And it has a structure that tries to make guesses about like how much like about the ranges at which snapshots differ. So maybe, but that's not, I don't think, a really accurate accounting. So like the way it would be doing that copy is like, you know, copying the snap ID at the ranges it knows they're different and sending them around. But that could inflate space usage. I think. And I'm not sure how much that is different from just doing backfill. So it might be that this isn't a big deal, but it's something I'd want to refresh myself on or talk to people in the Rados team who work on those interfaces more to talk through.
Well, in Blue Store, clones are just preserving differences, so at least that part is not expanding more space than it should. But obviously, if you backfilling snapshots with new data, then that information is lost. I'm not really sure that we do a proper diff on backfilling clones, I mean snapshots.
So like, just as a trivial example, if we write the same data block, exact same data block, or I should say same object twice, spanning a snapshot, Blue Store may actually have two copies of the data, or will it compute the diff?
It will not internally diff. It will just rely on OSD invoking first clone range on all the rest of the object and then filling the diff. And internally, Blue Store is not doing any comparison with head object or snapshot or anything to deflate the space.
Okay, so like the MDS couldn't do this today in an efficient way, because just the naive thing to do would be to copy past snapshots to an object and create new snapshots as you go, and then copy the head. You would end up potentially with n snapshot copies of the data, right?
Yeah, that's correct.
Right, but that would be if you go by the that structure that Greg mentioned that stores the ranges. If I'm not sure why Greg thought that it may not be exact. It actually is down to single bytes. So if you do that, then you can reconstruct the snapshot history without inflating space usage. This is what RBD does. So when I was asking about what is it that you mean by efficiency here, RBD has support for this. It has the RBD deep copy command, which is unlike the regular copy. Takes care of the snapshot history. It does this for the entire image. It's going object by object, and the way it's doing it is it's basically reading data. So it's client-driven operation. The client is reading data from all of the snapshots and the head, and then reconstructing, and then writing it in a very particular manner to reconstruct the snapshot history. And it's based, it's driven by that snapdiff thing, which Greg mentioned, which is the structure that is maintained at the OSD level. It's not an object store thing, so not a BlueStore thing. Adam is correct that BlueStore doesn't know anything about that. But as long as you kind of sequence these operations correctly, and kind of leveraging the fact that you can actually write, you can modify the contents of the snapshot after it's been created, combining these two things does the trick. I mean, snapshots and radius, they are mutable, and that's what allows to. So on the one hand, it's a major thing for. I think we had some discussions about a project that wanted to ensure that snapshots are actually mutable, and then such that no malicious client could do this. So the front model was that you have access to the cluster, so you can potentially have a rigged libRadius or libRBD kind of issue requests, and we wanted to see whether it's possible to kind of prevent the clients from doing this based just on CephX caps. And today there's no way, because if the client is allowed to write, so if the CephX profile allows a write to the object, that client can modify any of the snapshots on that object as well, so it can effectively trash the entire snapshot history. And then your mutable snapshots aren't really mutable, so you can't you can't really prove that to an outside system for some kind of ransomware protection, for example. So there are scenarios where this bites, but in this scenario, in the kind of data migration scenario, the fact that snapshots are actually mutable helps a lot, because this allows the reconstruction without ballooning the space utilization.
Just a quick side note here, from BlueStore perspective, both head and any snapshot is fully modifiable.
Right, and it's the same from the OSD perspective, really.
I wonder if we could have like a CephX restriction, like to only write to the head. Is that something we've discussed in the past? It's like we would want to use that for CephFS clients too, for the same reason.
There was some discussion. The problem is that the OSD doesn't like the problem was that the write to the head isn't like, it's not a thing that is kind of easy to define. So it comes down to securing the snapshot context. So basically, to make this completely bulletproof, you need to make the kind of OSD hand out the snapshot contexts to clients. And then, so instead of having clients construct them from scratch. And then the other half of it is then enforcing that the client is writing with that same snapshot context, or a snapshot context that is compatible with the one that was handed out. Otherwise, there's just no way to. There's no way, like if you consider a malicious client, there's no way to prevent that from happening.
Well, there's something wrong has been said here, I think, which is once an object sees a higher snap ID, all older snap IDs are immutable from the OSD's perspective. It's not going to let you do writes with old snap IDs to objects that have newer ones. The problem is that we very deliberately, don't go out and touch every object in a logical snapshot. So that's something that like RBD could definitely do if it wanted an immutable snapshot, is just go poke them all and like with a, I don't know, touch a OMAP or something on them. But we're getting really far afield here, and we got a lot of stuff, a lot more things to get through. So maybe we should just move on.
Well, I just want to quickly point out, like for the RBD case, you could just, simply delete the object and recreate it. So you're always able to just modify a snapshot logically that way.
That's true. That's true, yes.
Anyway, yeah, I agree. I think, this is a good topic for discussion, but there's clearly a lot more design work that needs to happen before we can seriously work on it. So why don't we move on?
Yeah, I agree. All right. Let's see. Third one is 6 to 7. It's another tracker. 6 to 7 on 5. Manager volume, switch to storing subvolume metadata in lit SQLite. This is another one which is controversial. So we should discuss this. And yeah, I created this a while back. And I think so. We did have discussions. But mostly they were during startups. So this should be, a good one to talk about right now. So just a bit of history. The subvolume metadata, I'm talking about the CephFS subvolumes. They are like live in like normal files under the subvolume root. So these are like normal text files, actually just INI files. And, this has become a problem lately due to various reasons, which we have run into. I can describe a couple of issues that we had. One was related to the metadata getting corrupted, and the cluster was nearly full. So all the updates to this metadata file was done inline during the operation itself, and during cluster full, there was we ran into a situation where there was like a half-baked metadata file, and that which so we wrote a bunch of data. So the way it's done is like Manage Volumes has like a CephFS client, and it just does a write operation to this particular file. And we got a half-baked corrupted metadata. And we had to this was fixed. Portrait fixed it by writing to a temporary file and then renaming it over. So that was one issue. We also had a CVE come up like a couple of years back, involving the metadata file itself. Those are all like solved by working around in the code. However, recently we again found an issue, a problem with the metadata again during a clusterful issue, where basically an ordering problem between when the metadata gets updated versus when the operation is done. So, again, that required a fix by reversing the chain of operations. So all this is kind of now, prompting a discussion that we should move the metadata, which is now in a text file, to a SQL store. We already have libs of SQLite that I think so it's being used by a couple of projects in Ceph. And one other thing that moving to libs of SQLite gives us is, transaction ability. So you can like say, these are the, journaling, actually, you can say, before you do an operation, say manager volume scan, you can say, these are the set of operations that I'm going to do and, store them as a transaction. And then, once it does an operation, you can update the transaction and say, maintain state. So that's a neat thing. Yeah, but it also has its own set of problems. I remember Greg mentioning about, issues when we lose the DB itself, what to do, and that's a valid point. And so this is up for discussion. And I'll quickly point to the note in the tracker, which discusses the pros and cons. Greg, you did mention about recovering the database in case of things going bad. What can be done for that? I mean, we could obviously take backups of databases, but you could also reconstruct it, I guess, using some offline tools, which obviously we need to write. Something that scans the subvolumes and just like we do now. I mean, right now, because it's meta, you could like hand it the file or even like, drop in a custom metadata file. But with this, if the point of database recovery is the question, then you could write tools to kind of inspect each subvolume and derive a database out of it. And I'm sure that's possible.
Right. So as I said on the track ticket, apparently 11 months ago, it's really distressing that we need to account for this in developing features, but I've seen a staggering number of rook users just like delete a third of their data or a tenth of their data. And so I want, for a feature that exists mostly for interfacing with work, I want really robust recovery procedures. And I just don't know how to work with libceph SQLite well, and yes, we could. Patrick, I think in the ticket mentioned that we can, keep all this same metadata in the tree the way we do now, but just make it non-authoritative and update it after the fact. So if we do that and like build recovery tools into the database, then that makes me feel better. I'm also just a little leery because we're already overloading the manager and now we're going to run this extra database inside of it. That makes me a little bit nervous, though not like impossibly so. And then sorry, there's So you're talking about like, it is about transactions, and it is possible to build transactions of many stripes inside of a file system interface. But maybe we should just do that, or maybe I don't know. I've never really worked with databases, honestly, not as a client. So
Yeah, so
maybe it's much
kind of,
easier to work with a database than build file system transactions. But like, that doesn't. The fact that you need to build file system transactions, you still need to build database transactions and apply them. And then the other one is just like, we've seen, I don't remember how many CVEs from switching to subvolume V2. And so anytime we do a subvolume metadata switch, I'm going to be like, why are we adding or why are we going through this pain? Like, is it going to save us more and our users more in the long run? Because it's really hard not to introduce security bugs when you're introducing that kind of thing.
I mean,
Which
the
isn't
CB
like, again,
was,
a reason to not do it on its own. It's just like, what's the justification that it makes it worth those risks?
okay, the CB itself was related to the dot meta, so getting rid of it is actually a positive, isn't it?
I mean, but again, if we get rid of it, how do we recover if we lose the database, either due to corruption or user deletes random portion of their data, or maybe if we're not relying on it, that fixes it. I don't actually know, but
Well, to be clear, we're not actually changing the current reliability of the metadata by introducing this, because if we lose the .meta files, because we lose, like, say, a portion of the data pool, which has happened, you lose all that metadata today, and none of the metadata is really stored in the CephFS metadata pool, except as the actual layout of the subvolumes.
yes, but losing access to a random portion of your data is often awful, but it's way better than losing access to all of your data because you can't map any of it anymore. Which, if you have a single database that you lose, that's it.
Right, but we don't, as already outlined in the ticket, there are simple backup procedures like actual API calls in SQLite we can use to back up the database elsewhere. We could do a full database copy periodically to a file in CephFS, actually. Like, all of this is possible. So, I don't really see this as a big barrier for actually doing this. And we can also redundantly keep some of the data set as like X-adders in the subvolume, so that we can do at least a partial reconstruction if we just like lose the databases somehow.
Patrick, are you thinking more as like an availability or more as a like a redundancy thing for that? Like, would you be able to like just fail over to that like backup, or?
No, we wouldn't want any kind of failover to the alternate to the backup. You would have to have some kind of recovery or reconstruction of the database in order to continue.
Okay.
We're talking about like an extreme disaster where like the volumes plugin should probably just stop working and ask for operator intervention to fix the problem.
Okay. Yeah, I keyed in when you said available, I was thinking maybe you had meant in terms of like
no, I agree with Patrick.
Okay.
Like,
okay. Just I wanted to make sure I was clear on it.
Like I said, I hate that we're talking about this, but the reason we are is that a lot of people in Kubernetes who use Kubernetes are just staggeringly unfamiliar with storage, which in one sense is fair. And so they do things like turn off or like destroy 3 out of their 6 OSDs simultaneously, and then go, wait, why did my application stop working?
Yeah, we've recovered clusters for people that have done similar things. Actually, not in the Kubernetes, not in the Rook world, I guess, but just in other.
It's much more common there in my professional experience so far. So, and since this interface is principally for Rook to interface with us, then it's a very important design consideration. is recovering from that as best it's possible to do.
Have
So
you?
I just want to point out more generally, like the other real win here about using something like libsep SQLite is it opens up a lot of doors for us in terms of what we persist as far as operations on the volumes plugin is concerned. And like one of the most attractive things that we can do, which is really kind of essential for any kind of enterprise storage product, is auditing. We can actually record what operations the volumes plugin is performing. And when disaster eventually strikes, we can get something far more useful than debug logs out of the cluster to examine. Actually know what the volumes plugin is doing at any given time, what operations have been performed, what is it currently like trying to delete, what is it currently trying to clone, etc. And that's just completely non-trivial with how we currently organize the metadata in the volumes.
And that's way more attractive to me, Patrick, than any of the other arguments I've heard for this. So that's a good one.
Yeah. So yeah, there's already a tracker for that actually, but it's not like CephFS specific, but for like everything in Ceph. It's good to have like something recorded, audited for offline viewing.
We have a variety of tickets around like recording audit logs, and many of them have been fulfilled, but they're just impossible to work with or get directed off into the void or something. So having one that the volumes plugin just maintains on its own,
yeah,
that we know doesn't get messed with, is pretty attractive.
Have you considered the actual, like the disaster recovery in the like in the sense of mirroring? Because currently there is a CephFS mirror daemon, and with the metadata stored just in regular dot files at the top of the subvolume, that would be mirrored intrinsically. Whereas if you by doing this, you're effectively introducing an additional pool into CephFS. So apart from the metadata pool and data pools, you also have this dot manager pool that you suddenly have some critical state in. This is
we would probably use the metadata pool. Yeah, we already do that actually for the Ceph SQLite database that's used by the snap schedule module. It's not actually using the dot manager pool. And as far as I'm aware, the only thing the dot manager pool is currently used for is the device health metrics, which actually was what it was used for before, because we renamed the device health pool to the dot manager pool for more general use.
So there's a separate SQLite instance on that. Because I was under the impression that was supposed to be the only kind of libSQLite instance that is going to be used by all modules. And
no, it's just meant to be like a build it and they will come type situation. So like any module now can just trivially open a database that's stored persistently on the dot manager pool, and they don't have to think about like where to put it, or create a new pool just for their particular module. But up to this point, we don't actually have a second module that has tried to do that yet for various reasons. Except I do know that the Samba module is, if it's not been merged already, there's a PR open to store the Samba export information in a Ceph SQLite database, and I believe that's in the dot manager pool. But coming back to the volumes plugin, we would probably just put it in the CephFS metadata pool, like we already do for the snap schedule module, because the information in that database is just strongly coupled with the actual file system the subvolumes are for. So there's no particular reason to keep it in the dot manager pool, although we could replicate it there for disaster recovery reasons.
Okay. I think if it's part of, if it's stored in a CephFS pool, then the CephFS mirror daemon could potentially take care of it. So that seems easier.
So the CephFS mirror daemon is intended for geographic replication. It's not really configurable to copy only specific files. You give it like a directory and it does everything underneath it. And right now it's a toy. In our long-term work, I think I think farther down we have a thing here to talk about referent inodes and fast clones at the end, and that's kind of required before we can really use before I would consider the CephFS mirror daemon to be usable in any real scenario, except a very, very small proportion of your data in a very large system.
So with today's situation where the CephFS mirror daemon isn't really used, and in the Kubernetes environment we're using like an external tool which basically works with files. Does that tool interact with this? Like, does that tool like replicate those .ini or whatever files where the subvolume metadata is stored, or because that tool is kind of fat subvolumes to begin with, it never sees those files? Just curious.
It doesn't see those files, and it wouldn't need to, because those are working through Kubernetes interfaces to generate new mappings. So it's called fall sync, and they've got their own metadata they maintain for that mirroring process.
Okay, thanks.
Yeah.
All right, so I'm not seeing actually anything negative with this. Anything else to discuss regarding this? All right. So the next topic, point 4. That's another tracker. MDS manager, identify metadata heavy workloads.
Did we lose you, Banky?
No, I'm here. I'm just trying to retain what I actually wrote and see if something is missing. All right, yeah. So as mentioned, the tracker is coming from like folks in the field, support actually, and looks like something which would help in identifying issues beforehand. So right now, the MDS obviously throws a bunch of warnings when it's hitting certain limits, like cache memory limits and instances where it's trying to recall caps from clients, but the clients also, because and it's possible that the client is holding so many caps that the recall is slow. or not slow, but it has too much to do. So the MDS is like, in short, running close to its limits. Um, and the way we do when we get such reports, from our users is first thing we do is to ask for perf dumps and actually perf dumps based on intervals like 5-second interval perf dumps for say 10 minutes, and then we like manually go through the perf dumps and see which specific counters are like rising too fast. Just an example, you could see like if the MDS is, say the warning is, MDS is behind trimming. So the log journal is not getting trimmed fast. And to see that, we could, what we do is, what engineering does is to see the latency of like the journal, write operations, and also the latency in trimming operations. And if those are like really high, that points to something like an issue in Rados, which is causing such huge latencies in object writes or terms or deletes. So that has to be done manually. So the idea here is to kind of, in short, automate that. And, by having a manager module that could essentially collect perf dumps over intervals from the MDS or MDSs, and analyze say last 15 minutes of dumps. Maybe that's too huge. Maybe just last 5 minutes of dumps, and and warn that that the MDS is, if that rate of IO continues, the MDS could throw out warnings in the future. So um, how it records these perf dumps, where does it persist it, or does it just keep it in memory? That's all needs to be discussed. But the idea is to go over a set of interval-based perf dumps, and try to infer if some of those counters are rising too fast or are too high, and throw out a warning. This could also be something
Can we
like
afford to consistently take these perf dumps? I don't remember which things are expensive, but I know that like I've seen cases where gathering debug data, and not just the logs, because obviously the logs can go up, but just gathering debug data through the admin socket introduced measurable problems with the system. And I don't remember if just getting perf dumps can do that or not.
That, I think, sure was a problem which was identified in the during the Quires development cycle, where I think sure the main thread was getting held up, and I think that has been moved to an asynchronous way of replying. So other, like, that issue was when an ASO command is running, you couldn't like do anything else, and the finisher thread was getting held up, and I think so Leonid moved that to an async response so that you could do like other operations. But obviously you will be like doing operations under the MDS log, so you'll still be like holding the log.
I think what Venki's remembering is there were certain MDS commands that we were running, especially in the QA suite, which needed to be made asynchronous, and that means they don't block the thread. And actually, the ASOC, the thread that processes commands off the admin socket, cannot handle multiple commands at once. If I remember right, it's actually the tell command queue that you can actually handle asynchronously. Although may have changed, but I don't think so. And as far as the perf dumps, those have always been handled in a separate thread asynchronously with any lock, because all the perf dump counters are in atomic variables, if I remember right. So you can just have a separate thread process that without interrupting anything. You know, I think the danger that would be first discussed as far as this ticket is like, would the act of trying to collect debug information just exacerbate the problems in the cluster? Is it too much information? So I think, you know, to answer that, it needs to be selective. And this module could potentially be used outside of the scope of CephFS. If it is a new module, like you want to start collecting perf dumps at this interval from like all the OSDs or all the MDSs, and maybe some other metadata as well. Maybe like turn debugging on the MDSs for a short period of time when it observes this type of behavior. Or if it sees an MDS behind on trimming warning, it just automatically starts collecting perf dumps and then like records all that in a like a, sorry to be a broken record, like a libsep SQLite database, and says here's a database of all the perf dumps corresponding to this event. You know, you should look at it when you at your convenience to see why the MDS was throwing this warning. And that could be something that's kind of automatic that we could program into the module. Because right now, you know, you have a health warning, but you know, if it happened like 10 minutes ago, you don't really know what was going on in the system to cause it. Or, you know, like if you're looking at a cluster that is presenting some new problem, you know, it'd be really nice to say, oh, like 2 days ago, it was, you know, we had the beginnings of this trimming issue, and here's perf dump capture during that time that we can actually examine. We don't have any of that information. And it's very common to, I don't want to say it's very common, but, you know, often we see, you know, some clusters exhibiting a problem, but it's had a number of problems. And, you know, sometimes we don't even find out about the problems it had several days ago, weeks ago, until long after we're doing a retrospective to see like what the hell caused it to melt down. Whereas if we had a module operating in the background, like watching health warnings and say, hey, look, this is clearly a problem, and we program this behavior to capture this set of debugging. And then when we finally look at a cluster, we can say first thing, hey, we want to see if there's any events in this module to be examined. And we can try to correlate that very early on when we're looking at a problematic cluster, rather than finding out about these problems long after we've already diagnosed the issue.
Yeah, so what you're trying to say is we capture the MDS or whatever will capture these dumps around the point where these issues start to show up, right?
Yeah.
I mean,
The idea of the ticket
ahead.
is to try to warn the users beforehand that a problem may be showing up in the future. I mean, it might be heuristics and it might be wrong, but it's just a hint that, you know, something is really messing up. You need to go and check, or probably be ready to collect data in the near future, or start collecting data. You know, because the more data, the more idea you get of what went on. I mean, just
so
collecting data around the perf dumps is fine. I mean, it's not like it's total waste. It's surely useful, but if you could like see that the problem could occur, there's a probability of the problem occurring, you know, of the MDS throwing a bunch of warnings in the future. You know, that's also a a big plus point. Sorry, Greg, go ahead.
Yeah. I think this is sort of coming from two sources. One is that we're not very good at communicating what the limits of an MDS are, because, well, I mean, they're wildly unpredictable. It depends on the amount of speed of memory you give it, and it depends on, how the Rados cluster is doing, because we've definitely had, seen instances where they have just began on trimming because the Rados cluster can't provide the IO that is required to do trimming because it's overloaded. And because, our caps are pretty cool. So as long as everything fits, then a huge proportion of a system's total metadata throughput is just handled in client caches, and it never sees the MDS. But if you exceed those limits somehow, then you start needing to involve the MDS a lot more. And so you can get these, it's like you go from everything being in memory to nothing being in memory, and then everything's much slower. So partly it's about limits, and partly I think it's about the fact that it's difficult for anyone who isn't deeply versed in debugging the systems to know when they see a warning, if the warning is the result of a bug or a result of the way the system is being used. Like basically every time I see any cases from IBM or Red Hat, then there's a warning that client is failing to return caps. And is that because there's a bug and the client did return the cap and the MDS forgot about it, or the client thought it returned the cap and didn't? Or is it because, the client is trying to flush out 2 hours worth of bandwidth into Rados because it had that much memory and it was humming along fine until the MDS needed stuff back, and now it's trying to flush it out and it can't. And it's hard for people who aren't extremely expert in the system to know what those warnings mean, because they're catch-alls that are designed to warn you that there's something weird going on, but don't know what the actual issue is. And I bring that up because, so this particular ticket is about like, okay, let's try and provide even earlier warnings that maybe are a little more specific than the very generic warnings that just turn up in every unhappy system for no matter what reason it's unhappy for. And I think that's worth doing, but we should also keep in mind that, anything we can do to improve the diagnosability, preferably at deeper layers, but at any layer we can manage it is going to be really helpful.
Yeah, Chris has something to say. Go ahead, Chris.
Hey, yeah. So thinking about larger file systems, as previously mentioned, it can be very difficult to diagnose a very active file system. So what about this notion of using heat? So for instance, a directory could become hot if it gets really busy, or you could see a subtree does, and then we would essentially go and keep track of that and some sort of.
I mean, we already track heat, so assume that exists, as it does.
Okay, that could be a way to go and keep track of, hey, this directory is bad. This is thinking as a sysadmin, you can go and like, oh, that's this app that's running on it. You can figure out what's going on with it if you're doing something operationally to it.
Yeah, higher heat may not necessarily. Sorry, I'll just say this real quick. Higher heat value just means that it's popular, it's being used much, but doesn't really tell that, if the MDS will run into issues due to that particular directory. They're two different things, I think. Go ahead, Patrick.
Right, but I mean, making that judgment call is the hard part, and what the whole point is here, right? Like that's what this ticket is asking for is.
Yeah, but
via Manufacturer module, tell me if something's going to cause trouble before it happens.
Right. I mean, but not based off like just based on the heat of the directory. I mean, we have if the journal latency is too high, that's a really accurate predictive measure of, of the trimming warning showing up later. right?
Okay, so I mean that's a specific metric we've
Yes.
identified that you think we need to track. So sure, I'm sorry, I'm just not certain why you're saying that the heat isn't going to be a useful input to heuristics is all. Like, if we're tracking historical state, we can be like, oh, this directory got hot, unexpectedly hot, and nothing else in the system changed, and now we're overloaded. Like that actually seems like a really useful input if you say, hey, like here's this event, and here's, I don't know, the top 10 most hottest directories or something in the system. Or probably you would look at sub volumes for something like this, but
I guess I'll speak. So I think we kind of touched on this. We need to be careful about like which things we're going to build into the MDS versus which things we're going to build into the manager. So like if we're talking about the particular case of the journaling latency is going up for some reason, or it's just high to begin with, or we can build into the MDS quite easily, just warnings that hey, the journaling latency is unacceptably low. Possibly all of a sudden, you should look into that because it may cause other problems down the road. I feel like that type of warning is appropriate to build into the MDS. I think where you need to bring it a level up into say the manager is when the MDS is having some issue. Possibly it's something it's throwing health warnings about, maybe not. And you want to start to diagnose what the problem is, what the cause is, but you don't know what, like the MDS can't, just lacks the introspective facilities to be able to give you an answer. Maybe it requires human intervention. But in order to facilitate that, you need to start, collecting information that someone can actually inspect. And I think that's where the manager can shine because it can just automate the collection of information. There are some, but like if we're talking about, the cap related warnings, and the journaling latency, that's something that we could build into the MDS and probably should.
By building into the MDS, do you mean like throwing health warnings, additional health warnings, like now, or do you mean like dumping
So
something
like if the
somewhere?
MDS can determine that certain latencies are increasing, then sure, we could throw a warning in the MDS. Why do we need a higher level plugin to do that analysis? Unless we're talking about looking at a history that's longer than the MDS's current incarnation lifetime. Like if we're looking at a cluster lifetime of weeks and months, possibly years, and we see some kind of performance degradation, perhaps that's something that can only be identified by a long-lived plugin in the manager. Perhaps that that would be a suitable argument for building it in that level of the stack. But if we're just talking about something on the lifetime of an MDS, then it should be built into the MDS.
All right. So what I'm getting is the manager module makes sense to store like historical data. Like when there's warning that shows up, the manager will fetch the relevant information and persist it, somewhere can be decided. But this particular time, and this warning showed up, and at that point, this was the state of the perf counters, and dump it somewhere. And if the warning goes away, that's fine. Something, auto resolved. And say 2 weeks down the line, we get a real problem is when we rely on the historical data to see what really happened. Right? That's where you're coming from, I guess.
Yeah.
I will say one thing I'm concerned about there is the idea that we start collecting data when things go wrong, because that means that we're putting load on the system when the system is
Which is
somehow
already loaded.
overloaded.
Yeah.
That's a good way to build death spirals. So maybe we should just be, generating that and like I don't know what interval we could do it at every minute, and then we just like delete them if we don't see stuff that worries us as we go. I'm not sure, but
Hey, Milan, you raise your hand.
I think it'll be better if we collect metrics at a regular cadence until we hit an event. So we'll probably need to correlate metrics with an event to finally make sense of what's going on, rather than turning on metric collection at the event or warnings.
So you keep on collecting these and then have like trim them out, if nothing, Is that what you're saying?
Yeah, trimming is secondary, but we need to
I mean,
see a graph of how things progressed, and then like place events on the graph saying, hey, this is the place where the event happened, and this was the stats, these were the metrics then.
Yeah. And how do you, the real thing is, how do you do this without overloading the MDS? I mean, capturing these dumps and storing it somewhere periodically.
I mean, if capturing the dumps overloads the MDS, then I think we need to figure out how to get the information without overloading the MDS, because that seems like a problem in general, not just for this ticket. And I know some of it's always going to be true enough we can't, but
I don't think it's going to be an issue in the general case
Yeah.
for MDS. I'd be more
Yeah.
concerned about the manager module that would be built doing this for like every daemon, probably not just the MDS, which is one of the reasons why we automated that these metrics should be sent to the manager, but only some of the metrics, only occasionally. But now we're talking about building into the manager the collection of these metrics on a continual basis, possibly from all the daemons in the cluster.
and sorry to interject, but just the way you said that made it very clear. A lot of this already exists. Like if you deploy Prometheus, like that's what the Ceph exporter does, is that metrics collection. So we should probably, like, I know not everyone does, but maybe Rook does, which is mostly where this is a problem. So maybe that's something we can get from them, or have the system turn on automatically or something.
Yeah, right. Now we recall the Ceph Explorer is doing something similar, right? It's getting perf dumps, I guess.
Yeah, at a very consistent interval from everything, not just from the MBS.
Well, if I recall, it only collects metrics that meet a certain threshold. So it's only looking at a subset of them. So periodically we got tickets asking us to add something to the, I believe, useful priorities so that Prometheus would get them. But we're also looking at like debuggability, and sometimes we don't really know exactly what we want to look at, and many of the metrics that we want to look at are not necessarily interesting for Prometheus to collect. Maybe they should be, but I think we do need to look at like the Ceph exporter and Prometheus before we try to build anything here. Yeah.
Well, the Ceph exporter doesn't persist anything, and then Prometheus is really, we don't configure a standard. Well, I guess Rook does, but again, if we're talking about the general kind of help, that this manager module would provide with regards to presenting some historical data around the times when there were other warnings raised in the system, then it would be nice if it worked consistently. Whereas people configure their Prometheus instances in very different fashions. So it really looks like, or it feels like what we're like just listening to this is that we're essentially working around the fact that we don't have like a standard configured and instance for this sort of thing, where it's something that would be, that we could count on being available in any time there is a there is a user is coming in, or there's a customer case. That's something that can actually be looked at, and it's not configured in 100 different ways behind different sorts of authentication, etc., where like none of the engineers can actually look at it, because that's already that's a lot of graphs that are already there, which again most of them correspond to the perf counters at the useful priority, but my experience has been that yes, there are certainly there are cases where sometimes you want to look at all of the all of them, and if it's collected, for example, in a textual information in a source report, that that single shot, that's one-time dump is actually sufficient. And what is but what you where you need historical data for the most part is those higher level counters or metrics that actually also make sense to the user, and therefore us having access to such a set of Grafana dashboards that would be standardly deployed. Seems like that's the sticking point here. It's something that we've never had historically, and we continue to build workarounds for that.
So I just kind of have a follow-up for that, Ilya, like, because I've not had to deal with a support case for like RBD, and any of the Rados folks who want to speak up, it'd be nice to hear your thoughts. But like, are there certain things you routinely collect when trying to analyze a case that would, are there perf dumps you're collecting regularly that would make such a plugin broadly useful? Because this is something we always ask for with MDS performance issues that we get cases for. We're always asking for perf dumps at intervals to look at.
Well, for RBD, we don't, because we don't have a server-side component. The librd library or the kernel client produces, does not produce any perf dumps. librd, it has an admin socket that can be configured, but it's not configured by default. And even if it was, this would be, somewhere on either a hypervisor node or some client node that we wouldn't have easy access to anyway. So for RBD, we don't, and I usually, to identify, if Rados is being slow, I usually just go by kind of secondary metrics that are coming from outside of RBD. So either something in the cluster log or things like that. So for RBD, nothing immediately comes to mind. We might have some metrics related to RBD mirror daemon, which could be collected because that is a server-side thing. But for just a bare bones RBD use case, there's not much unless we start, unless we do something, fair amount of work to make clients send stuff over the wire periodically.
You could configure the clients to be able to accept tell commands. I'm sure that would go over well.
Still, I mean, you can accept the command, but then you need that data. You need a way to return that data somehow. And
right. I mean, you would have to implement like some kind of perf dump command within the kernel, but I think the people would panic if they saw the kernel driver binding a socket so that it could receive tell commands as a client.
Yep.
I think it would be a non-starter. So maybe that would have to be like some opt-in thing that it sends off to this plugin. But we're talking about potentially a lot of data being sent to a management plugin, and as we all know, it's kind of overloaded to begin with.
Yeah, even just to close the loop on RBD here, even for librd based deployments, this is often, this would often be QEMU running on a hypervisor node, and those nodes tend to be locked down, much more than the rest of the kind of cluster. And I'm talking about just kind of a set of nodes, not just a Ceph cluster, but a set of nodes that the operator is responsible for. They tend to log down their hypervisor nodes to avoid any sort of interaction with the virtual machines from the outside. And so I've run into situations where I would ask for something, and if that something is on some node that pertains to Ceph, the operator would easily hand over that information. But if that something is, even if it's just a few lines in a file that is on a hypervisor node, they just refuse to do that, or it takes 2 days because they need to get an approval or whatever. So that's another kind of line in the ointment for RBD here.
Mm-hmm. So Radek, I don't know if you're available to talk, but if you have from the OSD side, I'd be interested to hear your thoughts.
I'm here. The subsystem I would point that comes to my mind as very first one in core within the OSD's boundaries is Bluestar. It's pretty common, maybe not every single case, but many to get to request for perf dumps.
Okay, so I mean, it sounds like perf dumps from the OSD would be potentially useful if we collected that at some interval.
I think so.
Would it be useful, like, would you find the historical information in the perf dumps routinely useful if it were available, or probably just perf dumps surrounding the event in question?
The most important for Bluestar is usually a reference with history, and the further history, the more we can infer on what gets degraded with time. Usually just from a snapshot, it's difficult to pinpoint what's wrong unless it's some obvious, like we got a tight loop on allocator and we're burning cycles there.
Okay.
But on the other hand, the current perf counters we collect are unlimited with time, so they are not in any time window. So it very often we have to ask a customer to reset performance counters and then capture like 1 day of values. Otherwise, we have half a year in one value, and it's pretty useless.
Well, I mean, you can, like, if you had a day's worth of perf counters, can't you just, is it because of the biases for the averages? Is that's what's getting
Yeah, that's the problem,
useless?
that averages and minimum and maximum became useless if we capture over very long time, and we cannot be sure that high average is a result of recent activity, not some typical value that had always been there. But I agree, if we switch to capture perf counters periodically, maybe resetting, and maybe even each counter should have a different frequency to be reset to 0. Just thinking out loud. I never thought about that before.
Yeah, it sounds
Perhaps we could have like several versions of the same perf counter. So one that resets, once a day, one that resets once a week, and then one that is, just the current version where it never resets, and do that in a generic way for all of the integer perf counters that we have.
Yeah, it's interesting. If it could be done for free or almost free, then it would be a nice idea. But what I would like not to have to modify all perf counters for different scope versions in the code itself. It would have to be some overlay over existing perf counters module.
Like in a manager module, you don't think we could build in like a reset period into each counter? And we're really only talking
I guess we could.
Well, I was talking about this coming from the kind of perf counter framework directly. So when you register a perf counter, you register a single perf counter, but on the back end, it's 3 fields: one for the daily, the other for the weekly, and then the third one is kind of the without reset. And it happens automatically. Maybe we could have a flag for kind of opt out of this and have just have just the one that is kind of permanent. But I don't actually see a use case for that. So it would be nice to have just all perf counters behave kind of universally. It's 3 integers instead of 1 should not be a big deal.
Yeah, I agree with that.
Yeah, I like the idea.
So I think we've talked about several things. One is just like collecting diagnostic information for a historical snapshot of the cluster state. It sounds like that would be broadly useful. I know I would appreciate looking at that type of information. I think we're also talking about doing some kind of insights on that so that we can say, hey, this is an anomaly in your performance or metric, and it may cause problems in the future. I think there's like a separate kind of collection that could be done if we know there's a problem in the cluster. Like the MDS is throwing a health warning. Why don't we start collecting data every minute at a faster clip to try to see if we can get better diagnostic information for support or the operator or a developer to diagnose what the issue is at the time of the event. And then like package that up into a single file that can be pulled out of the cluster. That needs to be done in a way that's not obstructive to normal cluster operations. But in general, I don't really think that'll be too much of an issue because perf dumps are handled in a separate thread on the MDS side, and there's no locking that I'm aware of. So my instinct is that it should not be an issue. The main problem would be persistence. If the cluster is already full, then we can't really do that unless we store it somewhere in a local file.
So quick question,
Did I
where are you
miss
planning to
something?
persist? Where is you plan to store it right now? Like the MDS will store it in the pool?
Well, MDS not storing anything, right? We'd be talking about a manager module, I think.
So you're still, okay, so the manager module is still going to pull all of this out from different daemons, various daemons.
Yeah, I think it seems we have an agreement that that would be a useful thing. Like if you could see the performance for a Blue Store device from a year ago.
Yeah, okay. So somehow I got the feeling that manager module pulling out this would be like overloading the manager, which is already loaded.
Well, I think if we're talking about like regular collections just for historical tracking, it just doesn't need to be done at a frequency that we would consider consequential. Like if we did it once a week for each daemon, you could stagger that quite easily. And then you just need to have some kind of retention policy. For OSDs, I would say like keep a snapshot at least, if not monthly, then at a year. But like we're not talking about a lot of data here. So even if you had monthly snapshots of an OSD's performance, that would be quite useful, I think.
Okay, and just to be clear, if the MDS starts seeing issues like throwing out warnings, does the manager module like increase the frequency of collection?
Yeah. So there's maybe separate modules in actuality, but because of the overlap, it maybe should be merged into one.
Hmm. And the manager will obviously process this all in some SQL-like probably.
Well, that's attractive. I think, you know, the difficulty would be is if we're suddenly storing quite a bit of information, then we'd be, and like there's the cluster is near full or something in a small cluster, we should probably be able to have a backup plan of storing it in a local file on the manager if there's sufficient space, just as an alternate source of collection. I think storing it in Rados is attractive because it's just easier to pull out if you're generating an SOS report. I like it personally. But having a backup plan for local storage is probably wise. But the nice thing with SQLite there is you don't even need to care when you're generating the reports. It's the backend is irrelevant to you. That just needs to be configured when you're opening the database.
Yeah.
But you know, adding on to this, like not just perf dumps, but I would love to see things like config diffs, like knowing exactly what configs the daemon has, because the monitors don't necessarily have that information, especially if you're doing runtime config changes to a daemon. So if we had a snapshot of that, and some of the other typical admin socket commands that we ask for on an MDS, that would be really useful.
Yeah, basically everything that developers require to debug a thing is what we try to pull it off.
Yeah, this is like a Ceph developer SOS report because we're just always asking for things that we want to verify, like the daemon doesn't have any weird configurations or whatever beyond what's already collected in a normal Ceph cluster SOS report, which usually has a bunch of stuff that we don't usually ever care about because it's like operating system specific configurations that usually just don't matter.
Okay. Okay, so looks like we have a way forward, and we are in agreement with what we already spoke with with the manager being pulling off from various daemons and then adjusting the frequency as required.
I think I would say is additionally interesting as kind of like a stretch goal icing on the cake is if we can plug this into Ceph post file somehow. So like the community cluster is having some issue, we can collect the data and have it anonymized. The operator can review it if they want, and then have a follow-up command to just post that to the Ceph post file so Ceph developers can have a look.
All right, these are nice points. So I'll update the tracker with all this, and this would really be good to have it in the Tentacle release because we have been talking about this for long, but never got doing anything about it, or rather, did less about it. Anything else on this topic? All right, brilliant. Next one.
So
Implement
I just want to point out sorry to interrupt you, Venki. We've like far exceeded our time slot. Should we just I don't know if we can schedule another session to continue.
I think at this point we should just use the last 15 minutes until the next one starts.
Yeah, okay, the next two are probably just updates of what the current status is, so it should probably be quick, I guess.
Okay.
Next up in topic is implement FS script and let CephFS and CephFuse. Do we have Chris?
Yep, and it should be shorter. So just a little bit of background. FS script was added into FS script's encryption was added into CephFS via the kernel client the last few years. And that kernel client used existing facilities within Linux kernel that were for other local file systems. So last year or so, various members on the couple teams have been working on implementing it, FScript in user space, so bringing support to libCephFS, and then also CephFuse. So far, linked in the pad, there's a pretty big project plan of a lot of the tasks that I've been doing more recently. The major points are read and write paths are completed. So encryption happens for file name and file contents. The big haul was implementing a lot of the encryption decryption within the client or a library for it to do all those different cipher or do the different types of encryption. From there have been a lot of bugs that you can look through with testing the libCephFS, CephFuse in particular. There have currently all the tests that were set up for the kernel client are now passing in CephFuse that work through a lot of the read and write paths and different scenarios, different metadata calls, etc. We implemented the different types of ways to interact with in FScript in user space. So API calls, IOCTLs via Fuse. Some of the more major things are, as this is a interpretation of a kernel spec that we replicated in user space. We need to prove that there's interoperability between data written on one side can be read on the other, all the way from basic workloads up to the more complicated ones. And then various loose ends are needed to be done while we're targeting the Tentacle release for this new feature. And that's my boilerplate talk with time in mind. Any comments, questions?
I guess not. Thanks for your work on this, Chris. And thanks for the update. So we can move to the last topic, which is again a status update, reference inodes for fast cloning from snapshots. Kotrish, take it away.
Yeah, to give a little bit of background around this topic. So currently, whenever when we take a snapshot which contains an hard link file, so the hard linked inode gets snapshotted every time we take a system snapshot. So the reason for that is we don't have a way to track all the snapshots that are related to a particular file if it has hard links. So if there are multiple directories and the hard links are spread across different directories, and if you're taking a snapshot on a particular directory, so we have a dependency that whenever we depend on Rados for snapshot, so we have to send in all the list of snapshots during a Rados write. So because of which we need the list of all the snapshots, and as of today we don't have a way to track during a write on a particular file to list all the snapshots that are related to that particular file which has hard links. So currently the issue is being solved by having a global snap realm. So whenever a file is getting hard linked, so it is linked to the global snap realm, and it's a quick and easy way to solve this. Like whenever we write a file, we can just traverse through the global snap and get the list of all the snapshots and pass it over. So this is an attempt to solve this snapshot lookup problem, wherein we'll have a dedicated inode for the hard links as well. That would solve the problem of the snapshot lookup and make it easier and get away with this global snap realm. So I started this as a POC, and currently I'm still working on the complexities with respect to the multi-MDS, unlink and rename. I'm trying to resolve those issues. With single MDS, I kind of tried it, and it works as expected. So with multi-MDS, there's still things to be done and needs to be tested. Yeah, that's the current status of it.
All right. I'm sure we brought a point up in the last series for Squid, or maybe for Reef, but the upgrade parts are something that needs to be taken care of, right? With all the different hard links.
Yeah, there are a lot of other things as yeah, right. The updates and even the data scan tools, all
Yeah.
those needs things needs to be taken care of along with this. Yeah, that's right.
Yeah, I'm sure we like bought the point about updates, but we haven't thought about how would it actually fit in. So yeah, we need to also start thinking about those.
Those and also we need to that the point that needs to be taken care is right now with the current work I'm doing. The secondary hard link is using the same full-blown CI node uh, to store uh, as a referent inode. So that optimization also needs to be looked through going further.
Yeah. Okay. Yeah. Maybe we would want to keep it as it is if we obviously need to run some post numbers before making that decision. Yeah. But
Yeah.
yeah. Upgrades are a bit more important. Yeah.
I agree.
Yeah. All right. Thanks for the status update, Kopesh. I appreciate your work on this.
Thank you.
All right. So yeah, the pad is like lacking some of the updates, but obviously this meeting is recorded and I took some notes. So I'm going to update the pad. And is there anything else that we need to discuss? All right, so let me stop the recording.